see a lot of north, and you don't get a baseline, but you don't get up to the canyon, and you don't get some samples there to see if you have a baseline.
Okay. As part of this framework assessment, now this is not, what we're doing here is not the RI. It was really just to set the stage for the RI, give us some information. Now, I'm not sure what area you're talking about, but there are at least wells close, on the southern end, close to the site that were installed as part of this.
But I mean, further out.
Now, this is the furthest out that's been installed today. It's a framework assessment.
Well, I thought if you could go further out, you get a better baseline.
Further south?
For like arsenic, for example,
The baseline background.
if you take different wells, not that you have access to real estate, well sampling, but if you kind of, to answer the question of the arsenic, is if you get the well testing, you can get an idea of the geography of the arsenic and how much it actually does increase the closer you get to the line, or if it does all.
That's a very good question. It's dealing with the distribution of arsenic in water that's not affected by lime. What does that look like? And other chemicals too. That's part of the RI is to try and come to some understanding of what the background is. Now, the background of a site this size is not going to be one number. We're generally just backing up and looking at the 20,000-foot view. You got the Walker River here. That's contributing a lot of water that becomes groundwater underneath this mine. Okay? So yeah, we have sampling data of folks who sampled to the Walker River, so we know something about chemical distribution of a lot of water that enters and eventually goes under the mine. But as water moves through the ground, you know, we're talking about this is not rivers. The aquifer, water in the aquifer moves relatively slowly. This site you're probably talking about, 100 feet per year, maybe less than that. And then it'll vary in different areas. But water dissolves minerals. And on a site this size, background is not going to be one number. And depending on where you are on this site, relative to where the water entered the site, what the soils were that it moved through. So it becomes a real complex issue because we can't go back in time before the mine was here and sample that water. So we're stuck trying to look, like you say, up gradient, this direction. We're stuck looking at how the water changes chemistry as it moves to the Walker River and goes under. Water that may be coming from the bedrock into the soil, saturated soil. What does this chemistry look like? Because it's been moving through mineralized rock. And you got some water that's coming into this valley, much less than the river because it's got the range. So that also likely has different mineral content. And it would serve as at least background for some part of the site, probably not very far away from the range itself because it's not contributing that much water. But yes, as part of background study, we will look at things like that. We'll have to look at in different settings what the mineral content is in the water. And on a site this size, it's a complex issue, problem.
But to follow up on your question, yes, the only way is to establish some wells in different locations that you feel are representative of what background or natural concentrations of these chemicals might be. And that's prior to the completion of this hydrogeologic framework assessment. We didn't really have a firm understanding of where the water was moving. And you need to know where water is coming from and where it's moving to pick those locations to set as your reference point for what are natural concentrations. So that's where we're at right now.
Yes, sir.
We've heard that we need more study. How many more years of more study have we done there?
The question is handed over to someone who will hopefully answer that. So, and that's what we talk about. We're collecting data for different reasons, and we're collecting water from domestic wells to determine if it's safe these groundwater studies at these large sites, sometimes it takes 5 years to complete an investigation, and I don't know what the record would be, but we're trying desperately not to shoot for the record.
Are we pushing the record?
I don't believe we're pushing the record, but I think we have some good researchers in the community who have kind of taken us to task on that and have done some research on how long it takes to investigate cleanup sites. So, at a lot of sites, these investigations are phased, so you can't necessarily put wells in 100 locations at once. So, as Robert was discussing, you need to determine where the water's coming to the valley, set some of the boundary conditions so you know where to put wells. It's a large site, and so that's why we phase investigations. And we're going to be, I actually think we're ramping things up. I think we're at a stage of knowledge where we're going to be ramping up things considerably over the next year or so. So I say ask us the question again in a year and see how you feel, how much progress we've made the next year.
My concern is that we keep covering up a problem and never cleaning it up. And while we're waiting, people still can't get rid of it.
Yeah, so I think it's a good question. So one of the things we're looking at is this bottled water program, which is always intended as an interim solution. We're just saying, is that even adequate? And like a lot of these problems, we're eventually going to have to say, what's the final solution for fixing the problem? But we can come back to that. We just want to go.
Thank you. First off, you've got the same slide in both your presentations, and I'm looking at the one, where does water well come from? And as a novice looking at this, and the emphasis is that we're talking about an area 4 miles by 7 miles. There's an arrow that goes to the Anaconda site, then it shows contaminated, and then possible contamination. And if you look at this, you'd think, well, boy, that's going out there 5, 6, 7 miles. Now, to be honest, how far are we talking about contamination? And how do you even guess and put on a slide possible contamination when you don't know it, or it wouldn't be possible? So I just really feel disturbed that you even put a slide in here once, and you've got it in here twice.
I think that's a fair question. It was always intended as a representation, and so we had to just switch some points of reference. And frankly, what we're talking about tonight is investigations of the mine, groundwater. Generally, that's why we're here. We wouldn't be working on this site if we didn't think there were impacts from the mine. So, looking at some of the chemical distribution maps, for example, if we look at sulfate or uranium, if you look at the site boundary, which is approximately here, you still see some considerable concentrations of uranium well above the maximum contaminant level. And this is a distance of, I'd say, 1.5 miles to 2 miles. So,
What we had said was that was not a technically exact representation. That was just supposed to be representative of just groundwater in general, using the mine as a focal point and the potential for contamination to move in the bedrock and in the alluvial into drinking into wells that are at different depths.
right,
Correct?
that's true, but and so I take the comment that it may be an unfair representation. We try to look at it in that fashion, but I also think it's not that far from reality. We try to make it.
What is the distance represented on this?
Oh, on that figure? We don't have a scale on that figure. It isn't. It's purely.
When you keep emphasizing 4 by 7 miles, it looks like when you get out here, you're probably out there 7 miles. Give us an idea of the contamination. Is it within a mile? Is it within 5 miles? What is it?